Hello. So now that we've been able to hook up the uh, pressure and temperature sensor and the accelerometer, we now want to add in our SD card module so that we can save that data onto the SD card. What we're doing is called a FlatSat in space industry. That's basically when you have all of your components spread out flat on the desk and you just hook them up to make sure that they're working. So we want to do that, have our final CANSAT configuration running on the desk before we start to integrate it into the CAN. So I have the SD card module. This is the circuit diagram that we have now with just the BMP and the MPU sensors hooked up. I'm now going to add in the SD card sensor or module the way we hooked it up in our previous tutorial. So I will put those wires in 10, 11, 12, and 13. There we go. And I can hook this up to the plus 5 volt and to ground. And so now we have our SD card module hooked up, and we're going to add in code that we used from the SD card tutorial into our current program, the way it's written now. With it's been cleaned up a bit. So there's something I want to show first when we do this. Here's my program that I finished at the end of the code lesson, and I want to just compile it first and show you something. So here it says the sketch uses 19,322 bytes, 59% of the program storage space, and the maximum is 32,256. And global variables use 1,124 bytes, 54% of the dynamic memory, leaving 924 bytes for local variables. Maximum is 2048. So the Arduino has two sections of memory, one for the program and one for all of the global and local variables it uses in your procedures. Now, first thing I need to do when we are going to start adding in the SD card, I want to include the sd.h library header, which has all of the declarations that we need for using it and the definitions of the procedures that we'll call. Now when I compile that, you see now the sketch uses 22,962, 71% of the program storage space, and 84% of the dynamic memory, leaving only 314 bytes for local variables. Now, an issue that I've encountered, and at least one of the teams I had talked to have encountered this as well. So I'm going to upload that to the Arduino. So you see, it goes through the initialization and then it starts printing out garbage. And the reason for that is that because we've used up so much of the memory with the header files and the declarations, it says only 314 bytes for local variables. Now, in my program, local variables would include anything like the strings that I'm printing out when I do the setup and I say we're initializing and then the initialization was successful or not. So we have a string here which looks like it's about 35 characters long, 35 bytes long. Big long string here which is I would guess somewhere around 60 to 70 bytes long. Many more strings. We're printing out temperature, pressure, approximate altitude. Each of those is taking up some of that 324 bytes, which are all that's available for local variables. Here's another print line, the Adafruit MPU 6050 test. String it's found, printing out what, just verifying what the accelerometer range is set to, another string there, and those are all taking up memory. And what happens is that it completely fills up the dynamic memory and actually can overflow. It'll write into the program space, and then your program will just be trying to run garbage. It's just not a valid program for it, and so that's why we're getting these strange looking letters. Or in one case when I had it, it would print the first two lines of initializing BMP, then initializing the MPU, and then it would go back and print those two again and again and again. And it's just an artifact of writing things, variables over the program space. It causes all sorts of bad things to happen. The sensor events, so when we read the accelerometer, each of those takes up 36 bytes. So just those three variables alone take up over 100 bytes of the 300 that's available. So we have a memory problem, and the way to solve that is to get rid of a lot of the strings that we're printing out. So when I set up the MPU, I'm going to cut it down to, the absolute bare minimum. If it failed, I'm just going to say failed. I don't have to be so verbose in everything. Found or success. All this afterwards, accelerometer range set to blah blah. I don't need that really. I have the call here to set it up, and I really don't need to say what that is. So I'm actually just going to get rid of all that. That'll save a bunch of space. It then sets the gyro range, and as long as you remember what the valid ranges are that you can use to call this program, I don't need to print that out either. The filter bandwidth, and again, I don't even know what that really does, so I'm just going to get rid of all of this as well. I don't need to print out to verify that I set it to the value that I set it to. So that cuts out a lot of space. Approximately, that's probably okay. The BMP, initializing the BMP 200 or 280, and I'm just going to say failed. We know that if it fails, it's possibly because either it's a bad connection or because it can't find the BMP sensor. So that's really all we need to know, and we can go in and fix it later. And then so BMP found, I'm just going to say success. Read MPU, that's probably okay. Now I'm going to compile that, and let's see now. So because the program I took out a lot, I've got now 596 bytes. Doesn't sound like a lot, and it isn't. It's about the same amount that early home computers of the late 1970s had, but by structuring our program a little bit more efficiently, we don't use as much memory. So I will upload that now, and you'll see that it uses a lot less memory, 596 bytes only. Uploads it, and let's clear that. Initializing BMP, success, and now it starts printing out the data. So now that we've done that, I can copy or create the rest of the code that we need to write the BMP and MPU data onto the SD card. And to do that, it can actually be very helpful to have up the code from the SD card tutorial. We can sort of can refer to it, but I might be able to copy some of it over as well. So first thing is I need a file manager or file handler. It's called file data type, my file. I also want to create a string, my file name, and I'm going to set that to mydata.csv. So I'm going to create this. I mean, it's printing it out as a text file, but by putting the suffix CSV, that denotes a comma-separated variable file. So the data that I save is just going to be a row of numbers separated by commas, which I can then easily load into Microsoft Excel in order to plot it on a graph. So I have my file variable and the file name. I'm going to go down into Setup, and after everything else is done, first thing I want to do is, where are we here? I want to open the file for writing. Instead of myfile.txt, it will be the variable name myfilename for writing. And then instead of serial print, I want to myfile.println, and this is going to be the header, the top row in the data file. So I'm going to save the temperature, pressure, and altitude from the BMP sensor, then AX, AY, AZ for the acceleration and XYZ, RX, RY, RZ from the rotation values from the MPU. And then remember, it has a temperature value as well, so I may as well save that. I'll call that temp2. And then I want to close this. So that's my setup. It creates a header line. Now in the loop, I'm going to want to print out all the values. What I will do though is I will create a new procedure, void save data to SD. I guess I can capital, no parameters, and just copy those lines over. So for this, what's the first thing I want to do is again open my file. So myfile.open. For writing, and then I can now copy over read from the BMP. Instead of printing to serial, I'm going to print to my file. So I can copy and paste those, and then every time it says serial, I can just replace that with my file. And I'm sure there's a replace function, but I'm just not going to bother figuring out how to use it right now. So prints the value, and instead of the units, it will print out a comma, and I don't need that. So that prints out the temperature, the pressure, and the altitude, approximate altitude from the BMP. Now, shrink that, I want to read the MPU values. Now remember, there is three variables that are used for reading the MPU values. So I have to declare the variable again in this procedure. And then down here I will get that event. I think I'll put in a couple of comments now just to help. Read the values from the BMP, and then read the values from the MPU. And just like up above again, and I will copy over the serial print values and just replace serial with my file. I don't need that. I'll do that first. I'm double clicking to select the whole word serial, and then, oops, Control V to paste. Okay, so back up to the top, get the values, print the acceleration, and I will print just the comma, print the acceleration.y, and comma, then print acceleration z, and, oh, instead of a print line, just print another comma, and then the rotation values. I don't need that. I will print that and print comma, then print the gyro value, rotational value around y, and comma, and then around z and comma. I want it to be a print, not a print line. And then finally, my file.print line temperature. And that's it. And then the final thing I need to do is my file.close. So that's my procedure to print out all of the values just in one line. Oops, print line, print line. Print line is only print. Okay, so that prints out all of the values, should print it out all values into one line. And then down in my loop, after I read the BMP and the MPU, I will then say save data to SD. There, that's it. That should hopefully work. Let's see if we can compile and upload this. Let's see if I have any mistakes. Nope. Worked. Excellent. So, serial monitor. Loading, and here we go. Printing out all the values. Oh, and by the way, I've discovered online a way of getting the program to not print out that little fragmented bit at the beginning before it runs. What happens when you upload is that it starts to run right away, but the computer issues itself a reset to restart from the beginning after a very short time, and the recommendation was just to put a delay in of 2 seconds. Suggested a little bit less could work, but I haven't been experimenting. I know that it will work with 2000. So if I do that again, and I will get rid of all the old data. Now you notice it's getting ready to run, and it doesn't print out the fragmented part. It prints out success, success, show at the beginning, none of the fragmented part. So yeah, that seems to be working, and now the only thing to do is to look at the file on the SD card to see if it has saved my data in a CSV file. USB drive H. There, mydata.csv. It works. And if I double click on that, it will load it into Excel, and everything will show up in a column. So that's, I'll stop that there for this first part of the FlatSat, and I will create a second tutorial to just add a couple more things into our FlatSat. An LED light would be nice to indicate that CanSat is on and working properly. And then next thing we're going to do is add in the power switch and the battery so that we don't need to run it from the computer connected to the computer through the USB port. So, thank you very much, and I hope that works as expected for you.